All right. A rational function is basically a function where it's the coefficient, right? The function itself is the coefficient of two polynomial functions. So you have f of x equal to a of x over b of x, right? And so the domain is all of the numbers except where the denominator equals 0. So to find the domain, you would set the denominator equal to 0, exclude those numbers, and that's your domain. All right? And rational functions, many of them will have asymptotes. Okay? All right. So what are asymptotes? These are lines that the graph comes exceedingly close to but never touches. Okay? All right. So a graph can have a rational function, can have a vertical asymptote, or many vertical asymptotes, or it can also, and it can also have horizontal asymptotes, right? So we're going to talk about all of the different possibilities of that today, right? Vertical, horizontal, and also there are slant asymptotes, which we'll get to in a little bit as well. Okay. So how do we find these asymptotes? From now on, you're just going to be able to do all of these by hand. You won't even need a calculator to figure these asymptotes out anymore, right? So a horizontal asymptote, by definition, is the limit of f of x as x approaches infinity and negative infinity. What does that remind you of? It's two words. Starts with an E. End behavior, right? So the end behavior can tell us also what the asymptotes are. All right, so to find this, right, remember how to find end behavior, all we had to do was look at the term with the highest exponent, the highest degree. Remember that? So here too, it's the same thing. To do this, all you have to do is look at the term with the highest degree on the top and the term with the highest degree on the bottom. Okay? So once you do that, if there is a lower degree on top and a higher degree on the bottom, then immediately you can say the horizontal asymptote is y equals 0. So for example, if f of x is equal to 5x squared plus 7 over 3x to the 4 minus 2x, right? Take the term with the highest degree on top, the term with the highest degree on the bottom, and just mentally compare them. Okay, there is a higher degree on the bottom, so immediately, minimal thinking involved, you say the horizontal asymptote is y equals 0. That's it. Okay. If you compare and there is equal degree on top and bottom, then the horizontal asymptote is the reduced form of the fraction. So for example, suppose f of x is equal to 3x squared plus 9, 5x squared minus 2. Compare the terms with the highest degree from top and bottom. Okay, x squared, same exponent. So the horizontal asymptote is just the ratio of the coefficients, 3 divided by 5. If you have to reduce, then you have to reduce. If there is a negative, then there is a negative. Okay? Yeah.
Let's say that for the first one, it was 5x to the third and x plus x squared. Do you have to add them up?
No. Just take the highest degree. That's it.
The highest and lowest from the top.
Yep. Yep. And then, if there's a higher degree on top and a lower degree on the bottom, then there is no horizontal asymptote. Okay? So if it's, let's say, 5x cubed over 5x squared, no horizontal asymptote. Now, one note here, if the numerator has a higher degree by 1, Then there is what we call an oblique asymptote. Still no horizontal asymptote. There is an oblique, a slanted asymptote, but we'll get to that later. All right. So that's for horizontal asymptotes. Vertical asymptotes, you simplify the function, and then you find the zeros of the denominator, right? But it's got to be the factors that cannot be eliminated, right? So for example, well, if f of x is equal to x plus 3 over x plus 3, x minus 2, right? Which one here gives you a vertical asymptote? The x minus 2, right? Only this one. The other one, x equals 3, is a what? A removable discontinuity, right? So the vertical asymptotes are also where you have infinite discontinuities, right? It's all coming together, okay? All right, so for the next few problems, let's just put all this into practice. We want to find the domain, the vertical and the horizontal asymptotes of these functions. Okay, so the first thing you should do is see if there is any benefit to factoring these polynomial functions on the top and the bottom. By that I mean, are you able to factor and cancel anything out? If not, then you don't have to. All right, so to find the domain, right, it's the denominator that's going to give me an issue. So I set that equal to 0. 2x squared is 34. X squared is 17. X is plus or minus root 17. That's where the denominator equals 0. So the domain is negative infinity to negative root 17. Negative root 17 to positive root 17. And root 17 to infinity. All right? Okay. So what about the vertical asymptote? Well, the vertical asymptote, it's nothing from the denominator cancels, so it's again where this equals to 0. So x is plus or minus root 17. Those are the vertical asymptotes. And remember, the vertical asymptote is a line, so it needs an equation. Okay. Horizontal asymptote, by definition, it's the end behavior. Okay? But I don't want you to go like too formal on this. For the horizontal asymptote, you look at the original function if you've factored. An extra I there. So if you ended up factoring this one, I like to look at the original function. So look at what we have here. Term with the highest degree, term with the highest degree. Same exponents, so you just say y equals 5 over 2. Okay? All right. So suppose you forgot the rule, right? Suppose you forgot, you got confused of the rule. What it is really, it's the limit as x approaches infinity of that first term over the first term, or the highest degree with the highest degree. So what happens? Oh, this is a 2. These cancel, so that's just 5 over 2 anyway. Okay? All right. Let's do another one. Here. Let's see where the denominator equals 0. 2x squared plus 1 equal to 0. 2x squared equals negative 1. X squared equals negative a half. X is plus or minus root negative a half. What is that? What kind of number is that? That's an imaginary number, right? So what does that mean? Where is the denominator 0?
Never.
It's never 0. The denominator is never 0. So this is imaginary, which means the denominator is never 0. Well, if the denominator is never 0, then we don't have any issues with the domain, do we? That means the domain is all real numbers. Okay? All right. Next, vertical asymptote. If the domain is all real numbers, are there any vertical asymptotes? Nope. Okay? All right, horizontal asymptotes. Take the highest term over the highest term. Y equals 4 over 2. Y equals 2. Okay? Questions? What's that? Okay. All right, let's do another one. What's the domain for C? Where is the denominator going to be equal to 0? At x equals 17. So I say the domain is negative infinity to 17, 17 to infinity. I think it's because of the Zoom that it's doing that. All right, so if you're on Zoom and you want to ask me a question, you can just chat me, because I don't know if I'll be able to hear you. I'm going to turn on the volume here. It's giving us feedback. Okay. Let's see if that helps. All right. Okay. What about the vertical asymptote then? X is 17. Good. Horizontal asymptote. 6x squared over 2x. There isn't one. None. Okay. Let's see why. Why is there no horizontal asymptote? Because technically it's the limit as x approaches infinity, 6x squared over 2x. Okay? But what happens here? These x's cancel, right? So, and when the x's cancel, what do you have left? 3x over 2. What happens when x is infinitely large? What happens to the y value? When x is infinitely large over there, what happens to the y value? It will be... Here. If you have 3x over 2 and x is infinitely large, how much is it? It's infinitely large, right? So that means it's just going up to infinity. It's never leveling off at a horizontal. It is 3x, but remember, we're looking at when x becomes infinitely large. Then the whole thing will be infinitely large. Okay? So for now, you don't have to look too deep into that. Just memorize the formulas, okay? And just say if more x's are on top, then there is no horizontal asymptote. Oh, okay. All right, so it's 3x. But still, when x is infinitely large, what is it? Infinity. Okay, that's what I want us to focus on, yeah? All right, so let's move on. Okay, so this one, let's factor it. This is one that we can factor finally. It gives us it makes things a little bit easier. So the domain is negative infinity to negative 4, negative 4 to 2, 2 to infinity. Okay, vertical asymptotes. Do both of these give us vertical asymptotes or just one of them?
Both.
Both. So x is negative 4, x is positive 2. Okay? So, whatever values your vertical asymptotes are at, they must have first shown up in the domain, right?
Yeah.
They must be discontinuities in the domain. So everything from the vertical asymptotes is part of the discontinuities from the domain.
Well, because constant goes with the denominator.
Exactly, but not every discontinuity that shows up in the domain is going to be a vertical asymptote, because they could also be holes. All right, horizontal asymptote. This is where I like to go back to the original function, because I can see the original degrees, right? If nothing has canceled. So it's y equals 0. Okay? All right. So now, take a look at that function. Once we know all of this, we're actually going to be able to graph that function by hand. Okay? Never in your life did you think that would happen. But look at that. Today happens to be the day. So let's do it. Okay. To do this, we want to first find the domain, the asymptotes, and all of that stuff. So domain, right? Let's factor this, is x plus 1, x minus 2, x plus 2. So domain is negative infinity to negative 2, negative 2 to 2, 2 to infinity. Okay? All right. Vertical asymptote. X equals plus or minus 2. As long as you put x equals in front, you can do plus or minus 2. That's fine. You know what? Let me just put that up on my graph right now. So at x equals 2 and at x equals negative 2, we have vertical asymptotes. Okay, the horizontal asymptote, right? X over x squared is at y equals what? 0. So let's put that on there as well. Now, if you're working with a pencil, which you will be on your tests and quizzes, and it's y equals 0, just put the asymptote like a hairline above, okay? And I've been doing this, I've been teaching this stuff since like way before you all were born. So my eyes are really trained to find those horizontal asymptotes. They're also trained to know that there is the horizontal asymptote shown on your graph. So, all right, so you're cool. There's rarely any ambiguity where a student put the asymptote and I didn't see it, okay? But like make sure you do go like a little bit above here. Okay. Now, next, in order to graph this, one thing I also want you to find, because we need some points, right, to like anchor this on our grid, I want you to find the zeros. For the zeros, what you have to do is you have to set the numerator equal to 0. So here, x plus 1 is 0, x equals negative 1. So at x equals negative 1 here, there's a 0. Now, at this point, it's a good time to pause and talk about asymptotes, right? So vertical asymptotes are lines that the graph comes close to, but it can never touch. The graph can never, ever cross or pass through a vertical asymptote. Right. So a vertical asymptote, solid lines, no graph can pass through. A horizontal asymptote, how did we define a horizontal asymptote? We said it was the end behavior, the limit as x approaches infinity or negative infinity. That means horizontal asymptotes only take effect, only take effect at x equals, or x approaches infinity, and x approaches negative infinity. All right?
So you can still have 0.
You can still cross, exactly. So you can have a horizontal asymptote like this. The graph is bound to follow the asymptotic behavior, is what we call it here. But then it can cross. It can cross 1,000,000 times as long as at the very end it follows the asymptote. Okay? This is a subtle thing, and unfortunately, like, I've even, over the years, I've even seen like math teachers, get this wrong sometimes, right? But it's subtle, but not. It's an important thing. Okay. So here we go. Okay, so now these vertical asymptotes have divided the plane into 3 regions, yes? Okay. In the middle region where the 0 is, right, if you want it to draw the graph, okay, so if it has to follow like the asymptotes, the vertical asymptotes, then one way for this to look is this, right, pass through the 0. Another way for it to look is this, right? So how do we know which one? Well, what we're going to do is we're going to use a test point. Okay? Let's just plug in a value. You know, take an x value from that region. Let's say 0. And we're going to plug it into the function. So we get 0 plus 1 over 0 squared minus 4, negative 1 over 4. So at x is 0, y is negative 1 over 4. Now there is no other way for it to look. Correct? So that's how that looks. Okay? Now, here we go. Remember in those old video games when a character went off of the screen on one side, it would re-enter from the other side? Yeah? That's what happens with asymptotes. So, if the graph goes off the screen on the bottom to the left of the vertical asymptote, it re-enters on the top to the right of the asymptote. Right? Goes off the screen on the bottom, re-enters on top. So now, take a look. It's got to follow the asymptote here. It's got to follow the asymptote here. Are there any other zeros in that region? No. So the only way for this to happen is if it bends like that.
What do you mean, are there any other zeros?
Well, there are no other zeros, right? Like when we found the zeros, it was only x equals negative 1. So there is no other place that that's going to cross the x-axis. Right? So same thing here. If it went off the screen at the top over here to the right, then it's got to re-enter at the bottom to the left. And again, in that region, there are no places where it crosses the x-axis. It's got to follow the asymptote to the far right, to the far left. So that's how it's going to look. All right? Yeah.
Does it matter where it enters? Like the x value where it enters?
No.
And you just kinda
Very
estimate
close
it?
to the asymptote, though.
Okay. And like for all the values, you can just kind of estimate it for that?
Right.
Okay.
So, so we put in some specific points here, right? The 0 and that y-intercept over there. And then the other ones, you could like eyeball it. It's fine. Okay? Yep.
Wait, how did you know to like why did you go to or it's not negative?
So there is no other way to go, right? So look, if it exits to the bottom here,
No, but like the middle part, since like is that a negative graph? Or like
so I knew that the 0 was here, right, at negative 1. And then at x equals 0, it's here.
the
So there is no other way in order for it to follow the 2 asymptotes there. Okay? But look at that. Look at that. Would you ever have thought you could graph that by hand? Right? But today apparently was the day, right? What's today? January 7, 2022. Today is the day. Mark it. Today is the day that you graphed a rational function by hand.
I'm gonna tell my kids that.
I know. I know. It's a worthy, yeah. It's definitely kid-worthy.
just like
Yep, you might. Yep. Okay. All right. Let's do another one. There's a little bit of a plot twist with this next one. So let's factor. I get x minus 4, x plus 3 on top.
You get 2.
Well, do you though?
Yeah, because right?
Yeah, why
Oh, we were just on campus.
Oh, zeros. I'm sorry, zeros. I thought you meant asymptotes. Yes, yes, you do get 2 zeros. Okay, so now the domain is negative infinity to 2, 2 to infinity. Vertical asymptote, x equals just 2, so there is just 1 vertical asymptote. What's the horizontal asymptote? Go back to the original function. So now look, I have an x squared here, And on the bottom, I have a 2x squared, right? So y equals what?
1/2.
1/2, because it's x squared over x squared, so it's 1 over 2. So right here. Aye, okay. All right. So Scotty, what are the zeros?
4 and -3.
X equals 4 and -3. -3 and 4. Okay. All right. So let's do another test point, right? Like let's go ahead and find the y-intercept. So when x is 0, what's y? It's -12 in the top, and then here it's what? 2 times
It's 8.
yeah, 2 times 4, right? So -12 over 8 is how much? Negative, right. So right here. Okay? All right, well, that kind of tells us how this is going to look, right? On the left side, it's going to follow the asymptote, cross the x-axis, and go down. So it's going to look like this. Oh, I can't see it. Just one sec. Oh, I keep my hands getting in the way. All right, let me do it this way. Okay, here we go. Now, here's where the plot twist happens. Remember when I said if it exited the screen on the bottom here, it's got to re-enter on the top?
Yeah, but it can't cross that.
Right. Well, so, okay, up here, right? Where did the vertical asymptotes come from? They came from here and they came from here. So now, what's the multiplicity of that first term over there? 1. If you have a multiplicity of 1 at x equals 2, it's got to switch signs. So if it ended negative, it's got to re-enter as positive. What's the multiplicity here?
No, it's still 1.
It's still 1. So at x equals -2, if it ended positive, it's got to switch sign and turn into negative. What's the multiplicity now?
2.
Multiplicity of 2 means it doesn't change sign. So if it entered here, if it exited here, it's going to enter on the same side and go there.
And that's only about multiplicity.
That's with multiplicity, because remember before, right? Suppose you had, y equals x minus 2 squared, right? There is a 0 at 2. The graph comes over, but because it's even multiplicity, what did it do? Did it cross the x-axis? It went right back. So if it was positive before, it ended with positive after. But if there was an odd multiplicity, what happened? It goes through. So if it was positive first, it was negative after. So with odd multiplicities, there is a sign switch. With even multiplicities, the sign stays the same. And it's consistent here. Even multiplicity, same sign, negative, negative. Odd multiplicity, the sign will change. All right? Isn't that super, super cool?
Yes.
I really think it is. Right, so that's where we're going to stop today. And for the homework, you're going to go up to number 29.
So you said that
I will give you lesson plans right now. All right, up to number 29, even though they are